Hello friends, welcome to this lecture on the mechanical properties of solid part 1. Though there are a number of properties, but in this video we will discuss only 5 of them. The remaining ones we will cover in the next video. Okay, so let me start with the first one, that is ductility. What is ductility? Suppose we have a metallic bar. Now I have clamped one end of this bar so that it cannot move. And on the free end, on the other end, if I start to apply tensile force with an aim to elongate this bar, what will happen? The question is, will this bar elongate or will it break due to these tensile forces? Now if it elongates like this, as we can see here, we can say that the material is ductile. Now if I go on stretching the bar, I will end up having a long wear. So what it implies is that ductility is that ability of a material to withstand tensile forces. And if a material is ductile, it can be drawn into long wears. Okay, so this is about ductility. Next in line comes the malleability. It is another property. Now let us try to understand this with an example. Here we take another bar. Now instead of tensile forces, if we apply compressive forces, what will happen to the bar? Will it deform plastically or will it fail? Well, if the metal bar gets converted to a flat plate like this, then we can say that this particular metal is malleable. So malleability is the property of a material to withstand compressive forces without breaking. Most common examples I can suggest here is gold, aluminium, copper, etc. It is only due to this malleability property that we are able to give a different shape to our ornaments, like this gold ornaments. If you go to a goldsmith's shop, you can see that they are continuously shaping this gold metal by beating it with a hammer. So it becomes possible due to malleability. Now if we have to compare these two properties, we will see that both the ductility and malleability refers to the material's ability to get deformed. On one hand, where ductility is the ability to be drawn into long wears, malleability means how well you can beat it into thin sheets. And also remember that ductility is associated with any material's ability to resist tensile forces, whereas malleability gives us an idea about how much compressive forces a material can resist. Okay, so the next property we have is the brittleness. So what is brittleness? Let us understand this with the help of a real life example. Okay, so here we have a refill and a chalk. Now if I bend the refill and release it, it comes back to its original position. You can see here, if I stretch it even more, the same result. But this time, if I deform it beyond its elastic limit, it cannot regain its original position. It is because the material has undergone plastic deformation. Now if I try to bend this chalk, it snaps at one go. No plastic deformation, nothing. The material fractures immediately. This is because it is a brittle metal or brittle material. Okay. Next in line is the toughness. Now what is toughness? Let us consider a metal block and a cardboard box. Now if I drop a 10 kg metallic block on the 10 kg metallic ball on the metal block, the block probably won't deform. Nothing will happen to the block. But if we drop the same weight on the cardboard box, probably this will be the consequence. The cardboard box will distort and break. Why this happened? It happened because the metal box was tough enough to withstand and absorb that sudden impact load. Toughness, therefore, is the ability of a material to withstand sudden shocks or impact loads, and it is usually measured in terms of the amount of energy a material can withstand before fracture. Now, since our cardboard could not absorb much energy before failing, it is therefore less tough than the metal block. Last property of the day is hardness. So what is hardness? Hardness is the ability of a body to resist indentation or scratch. Let us try to understand this with an experiment. Here I have a stainless steel spoon and a candle. Now if I take this candle and apply some force with the knife, you can see some scratches are formed on the surface. The candle is unable to take this force, so the scratches are formed. On the other hand, now if I repeat the same thing to the spoon, nothing happens, absolutely nothing. The spoon is still shining scratch free. So we can conclude that the spoon is harder than the candle. This is because we could not make any dent or scratches in the spoon. This is the summary of what we have learned in this video. Just pause the video for a second and take the notes if you want. Okay, so now time for two very quick questions. Number one, suppose I have a metal bar and I am trying to deform it using a hammer. Now after some time, if the metal changes its shape like this, what can we say about its properties? Just think about this, pause the video, and I'll be back with the answer. Okay, so the first obvious property is malleability. Why malleability? Because since the metal could successfully be beaten into a plate, so it has to have malleable property. And the next thing we can say about it is that this metal is definitely not brittle, because it would, if it would have been brittle, the metal would have broken, okay, would have fractured. Now in the second case, if we take some other metal and after beating it with hammer, if the output we get is this, then we can understand that the material is brittle since it has broken into small pieces. Okay, so this was all for today. Yeah, if you have any doubt, please feel free to ask in the comment section. Thank you.